Okay, and the final question for question 5 is 20 centimeters cubed of 0.0270 moles per decimeter cubed of sodium hydroxide is diluted with water and the solution is made up to 100 centimeters cubed at 60 degrees. Calculate the pH of the diluted solution of NaOH at 60 degrees. Give your answer to 2 decimal places. Okay, so there's 2 things to deal with this. We've got to figure out then, we've got a concentration of the sodium hydroxide at 20 centimeters cubed. We're diluting it down by a factor of 5 up to 100 centimeters cubed, and then once we've got the new concentration, we can then use that to figure out and using the relationship with Kw, figure out the pH, and that's the steps for this one. So let's start with this one. So in order to work out the dilution, we need to know how many moles of sodium hydroxide we've got here. So moles equals C times V over 1,000, so 20 times by 0.027 divided by 1,000 will equal 5.4 times 10 to the minus 4. So that's in 20 centimeters cubed. We want it's diluted up to 100 centimeters cubed, so therefore the concentration of the 100 centimeter cube solution is moles times 1,000 over volume, so 5.4 times 10 to the minus 4 times by 1,000 over 100, which is our new volume. That gives us obviously 5.4 times 10 to the minus 3 moles per decimeters cubed. Okay, now remember we've got a strong base, so the concentration of the sodium hydroxide is equal to the concentration of the hydroxide ions. So this number here is also the concentration of the OH minus. Now, if we're trying to figure out a pH of a strong base, we use relationship with Kw, or you can use the POH shorter version to work it out. If we do it in full, remember that Kw equals the concentration of H plus multiplied by the concentration of OH minus. Now we know what this is. We'll remember at 60 degrees, so make sure you use the right one from the previous part of the question. So we're rearranging it to figure out the concentration of hydrogen ions because we want the pH. So the hydrogen ion concentration is equal to Kw over the concentration of the OH minus. Now remember Kw at 60 degrees was on the previous page, and that was 9.311 times 10 to the minus 14. So actually you can't use your POH one so much for this one. It's best to use this. Okay, 3.11 times 10 to the minus 14 divided by 5.3 times 10 to the minus 3, which equals 1.724 times 10. I've just gone off the page there, let me bring it back down a bit. 1.724 times 10 to the minus 11. So that is my hydrogen ion concentration. So therefore pH minus log of that number, 1.724 times 10 to the minus 11, gives me, to 2 decimal places, 10.76.